So now we're doing Kaggle's Intro to Machine Learning Random Forests using a more sophisticated machine learning algorithm. All right. So here's the intro. Decision trees leave us with a difficult decision. A deep tree with lots of leaves will overfit because each prediction is coming from historical data from only the few houses at its leaf. But a shallow tree with few leaves will perform poorly because it fails to capture as many distinctions in the raw data. Okay. Even today's most sophisticated modeling techniques face this tension between underfitting and overfitting. But many models have clever ideas that can lead to better performance. We're going to look at the random forest as an example. And it's just, we're only going to be looking at it as an example because they don't tell us what's going on behind the scenes, except for this paragraph here. So the random forest uses many trees and it makes a prediction by averaging the predictions of each component tree. Okay. It generally has much better predictive accuracy than a single decision tree, and it works well with default parameters. But if we keep modeling, we can learn more models with even better performance. But many of those are sensitive to getting the right parameters. Okay, so yeah, basically at this point, it seems like we're only going to learn how the decision tree works, and we're just going to have to say, just going to have to let them say, trust me, bro, on these other models like random forest and whatever else there are. All right, so here's an example. So we've already seen the code to load the data a few times. At the end of the data loading, we have the following variables: train x, val x, train y, val y. And then here's that code. We've gone over it plenty of times. And then here's the little train test split at the bottom, right? So we build a random forest model similarly to how we build a decision tree in scikit-learn. This time using the random forest regressor class instead of decision tree regressor. There's got to be a list of all these, right? We'll find it. We'll find it later. So here's us importing random forest regressor. We've got the mean absolute error, and then we've got the model. We're going to fit it to, we're going to set the model to random forest. We're going to fit it with the train X and the train Y. And then we're going to do the prediction with forest model.predict val X. And then we'll do the print mean absolute error like we usually do. And you can see it's 191,000 instead of how it was before. Was like, I don't know, the lowest one was like 240 whatever thousand, right? So that's a pretty good step in the right direction, right? So here's the conclusion. Real short video. There is likely room for further improvement. But this is a big improvement over the best decision tree error of 250,000, we just said. There are parameters which allow us to change the performance of the random forest as much as we change the maximum depth of the single decision. What? There are parameters which allow us to change the performance, of the random forest much as we change the maximum depth of the single decision tree. But one of the best features of random forest models is that they generally work reasonably even without this tuning. All right, so we're going to go over to this one right now. Is that it? Yeah, this one right now. So there we are. All right, now we're on to exercise random forests, and we'll see you next time.